the second question that I want to talk to you about today is what happens when you dissolve something. So lattice energy is in a solid. And of course, that solid, when you dissolve it, you're going to break that lattice. So for example, sodium chloride, जिसकी हम lattice energy की बात करते हैं, if I add that to water, what happens there? So here's the thing. In sodium chloride, you have sodium ions, which are obviously positive charge, and you have chloride ions, which are negative charge. And they form this lattice, which you are able to, you have been drawing it or seeing it from very early on. Okay, so this is a rough idea of what that is going to be. And this is going to be sodium ion over here. And there you go. So this is a rough idea of what the lattice is expected to be like. Now, water molecule, we already know water is a polar molecule, which means water molecules, when they come here, they are going to have the positively charged side, which is the hydrogen ion or hydrogen side. So it's a polar molecule. There's a partial negative charge here, partial positive charge here. And at the same time, there's going to be the partial negative charge of oxide that's going to be attracted by the positive charge on the sodium ion. So they are going to attract each other, and they're going to obviously form these new bonds. But at the same time, you already have this bond. So this is the ionic bond. And this is a new bond, which is also being made. But at the same time, these two are force of attraction, and they're both electrostatic in the film. So this is going to be broken, and this is going to be made if you want things to dissolve. So अब होगा क्या? All the positive ions will be separated from all the negative ions. So eventually what we expect to happen is that this sodium ion will be surrounded by this water molecule on all sides. We expect it to be surrounded like this, ताकि उसका solution में वो पूरी तरह से dissolve हो जाए. And there's going to be bonds that are formed that are keeping it there. In a similar fashion, we expect the chloride ion to be surrounded by water, but it will be surrounded on the hydrogen side of water. So it will be like this. So there's going to be new bonds in there between these hydrogen slightly positive charges and the you get the idea of oxygen. I don't want to spend time writing the charges. But you get the idea that new bonds are being made. And for them to be made, these bonds that are already there, they have to be broken out. Okay? So how does that happen? So first of all, you need to break the sodium and chloride lattice. So you're going to have the reverse of enthalpy changes. Okay, so you start, reverse of the lattice enthalpy. So lattice enthalpy was sodium ions in the gaseous state and chloride ions in the gaseous state coming together, forming sodium chloride solid. Now we are getting exact opposite of that. So if lattice enthalpy was the delta H here and it was negative delta H, for this one, you will get positive delta H. So that's the first thing. You're going to see the reverse of lattice enthalpy. So that's the first stage. First, ये bond टूटेगी. ये जो इनकी bonds हैं, ये टूटेंगी. Second, ये नई bonds बनेंगी. We call this hydration. We say that this is hydration. Hydration is when polar water molecules, they form a solution of sodium ions and chloride ions. So chloride ion की separate अपनी bonds बनेंगी, which is called enthalpy change of hydration of chloride. और sodium ion की अपनी ये वाली bonds बनेंगी, and the delta H over here is, and this one, they are both the enthalpy changes of hydration. So first, you have lattice enthalpy that is broken, or lattice enthalpy का reverse positive में आपको मिल रहा है, जो आपको provide करना पड़ रहा है. And then new bonds are going to be made, which is the enthalpy change of hydration. So let me define this before we move on. So enthalpy of hydration, and there's another term that we're going to talk about later, enthalpy of solution. Let me define that as well. So enthalpy of hydration kya hai? It is enthalpy change when 1 mole of iron in the gaseous state, 1 mole gaseous iron is dissolved in excess water. When you say excess water, you're basically saying that the solution is dilute. और वो बहुत ज़्यादा dilute हो गया और उसके बिल्कुल ions बन गए, dissolve ही हो गया हर तरह से. So calcium ion अगर gaseous state में होगा और उससे वो calcium ion aqueous state में बन जाएगा, so the delta H of this is the enthalpy change of hydration. So what is the enthalpy change of solution then? How is this different? Enthalpy change of hydration deal करती है एक gaseous ion को water में dissolve करने से. But enthalpy change of solution deal करती है एक ionic solid को water में dissolve करने से. So they're only different in terms of what they're dissolving. So enthalpy of solution is basically 1 mole gas ionic solid dissolved in excess water. So common चीजें इन दोनों में क्या है? They're both about the thing dissolving in excess water. They're both about water forming new bonds with that thing. But किसके साथ वो bonds बन रही हैं वो different है. हाइड्रेशन में वो एक आयन है जो ऑलरेडी गैसियस है और वो बना रहा है, और सॉल्यूशन में वो एक सॉलिड है जो कि फॉरेन आयंस में कन्वर्ट हो रहा है. ओके, क्लियर? Any questions? So now, how does this lead to the whole solution thing? ये सारे के साथ वो कैसे relate करता है? Let's look at this. They are actually going to come together and form a heat cycle, which is very interesting. So we started off with sodium chloride, which was the solid, और हमारा मकसद है कि वो dissolve हो जाए. So sodium ions aqueous बन जाए और chloride ions aqueous बन जाए. They're dissolved in excess water. Or obviously to do that, I'll need to add water. This right now over here is delta H solution of sodium chloride because it is 1 mole ionic solid dissolved in excess water. At the same time, to make this sodium chloride, I needed these ions, but in their gaseous state. I needed the sodium ion in the gaseous state and the chloride ion in the gaseous state. And they formed sodium chloride solid. And what was this? This was the lattice enthalpy of sodium chloride. And what is delta hydration, the enthalpy of hydration? It is this same ion, the sodium ion dissolving to make sodium solution, sodium ion solution, and this chloride ion dissolving to make chloride solution. So this is delta H hydration of both of them. And clearly we have a picture here. क्या हो रहा है? You start with sodium chloride, individual ions, you bring them close together and then you dissolve them, and that forms the solution. Or you take the individual ions, you hydrate them, you dissolve them in water, individual gaseous ions. ये दोनों ही हमारे पास same conclusion पे पहुंचाते हैं हमें. And just the idea of law of conservation of energy. Energy is neither created nor destroyed. It's just transferred. So which means कि ये cycle है. आप कहीं से भी start करो. Let's suppose मैं यहाँ से start करता हूँ. The energy change between this and this is the same as energy change in this process. The path doesn't matter. The energy change is the same. The value is the same. Similarly, अगर मैं यहाँ से शुरू करता हूँ, the energy change here is the same as if I were to come from this route. So let me write that there. The delta H solution of NaCl is going to be equal to, so this side is going to be equal to opposite of this and then this. So it's basically negative delta H lattice energy of sodium chloride, which is obviously going to be the positive value, plus the delta H hydration of sodium ion and delta H hydration of chloride ion. Clearly. And there you have a very powerful statement. The delta H solution of anything, let me generalize now. The delta H solution is nothing but negative delta H lattice energy plus delta H hydration enthalpy. कहना क्या चाह रहा हूं, आपने एक आयनिक सॉलिड को डिसॉल्व करना है, पहले उसकी लैटिस तोड़ो, फिर वाटर के साथ बॉन्ड्स बनाओ. नो डिफरेंट फ्रॉम जो हम आईजीसीएसई में ओ लेवल्स में हम बॉन्ड ब्रेक करते थे, उसकी एनर्जी कैलकुलेट करते थे, बॉन्ड फॉर्म करते थे, उसकी एनर्जी कैलकुलेट करते थे, तो कहते थे ओवरऑल एनर्जी चेंज किया है. तो ये भी वही है. जो बॉन्ड्स आप तोड़ रहे हो वो लैटिस एनर्जी की हैं, लैटिस एंथैल्पी वाली हैं, और जो बॉन्ड्स आप बना रहे हो वो हाइड्रेशन एंथैल्पी वाली. And this is how it's coming out to be. So we have seen this. We have seen how anything can be converted and dissolved, and उसकी calculations हम कर चुके हैं और हमें आती हैं. All we need to know is we are giving it different names. आज हम उसको solution के अंदर बता रहे हैं, हम उसको lattice energy बोल रहे हैं, but at the heart of it, it's just bond breaking and bond forming, nothing else. Okay. Now, how does this relate to, and this is the last point for today, how does this relate to things dissolving? So this is an important concept, so pay attention. You have lattice energy and you have the delta H hydration. If the delta H hydration is more, remember, the negative of delta H is a positive energy. This is positive. And delta hydration is always negative. This is bond forming, this is bond breaking. अगर बॉन्ड फॉर्मिंग की एनर्जी ज्यादा होगी और बॉन्ड ब्रेकिंग एनर्जी कम होगी, ओवरऑल आंसर एक्सोथर्मिक होगा. So that means if the hydration enthalpy is more than the lattice energy, it will dissolve and release heat. But at the same time, if this is small and this is high, तो dissolve नहीं होने लगा. Because उसको dissolve होने के लिए externally energy लेनी पड़ेगी. वो एनर्जी वो कहां से लेके आएगा? हाँ, आप उसे हीट करोगे, उसको एनर्जी मिलेगी, तो ये लैटिस एनर्जी ब्रेक होगी और वो डिसॉल्व होगा. Which is why things dissolve more when you heat them, but not all the things, because it all comes down to कि भाई इनमें फर्क क्या है. If the difference between delta H hydration and the enthalpy is small, तो फिर तो हो सकता है कि अगर ये आपस में क्लोज वैल्यूज हैं तो आप हीट करके वो एनर्जी एक्स्ट्रा प्रोवाइड कर दें, सो दैट लेट्स एंथैल्पी की वैल्यू ओवरऑल कम हो जाए और ये डिसॉल्व हो जाए और एक्सोथर्मिकली डिसॉल्व. बट अगर ऐसा नहीं है, अगर उनका डिफरेंस ज्यादा है तो डिसॉल्व नहीं होने लगा. सो इफ the hydration enthalpy is slightly less than lattice energy, you can provide that energy by heating it. Okay? But if it is already higher, it will dissolve readily. But if it is lower and much lower, it will not. Now, most liquids, they dissolve in an endothermic way, which means most solids, sorry, they dissolve in endothermic, which means कि जब आप टेम्परेचर बढ़ाते हो तो इक्विलिब्रियम जो है वो आयंस की तरफ इन द डिसॉल्व फॉर्म उस तरफ को जाता है और वो ज्यादा डिसॉल्व होता है. When you, but there are examples जहाँ पे ऐसा नहीं होता. Okay. And yeah, so we'll continue exploring this idea, especially in the context of group 2 ions and group 2 salts. So I'll see you tomorrow. Any questions?